Have you ever really stopped to think about it? Right now, your phone knows exactly where you are. It knows the street you're on, which building you're in. Sometimes it feels like it knows what you had for breakfast. But how does it actually pull that off?
I mean, seriously, you can turn off your Wi-Fi, you can turn off your cell data, put it in full-on airplane mode, and yet you open up a map and there it is. That little blue dot pops right up. It really does feel like magic.
So what's the secret? Is it some hidden connection we don't know about? Is it somehow remembering where you were a minute ago? Or is it something way, way bigger? Something happening thousands of miles out in space? Well, today we're going to pull back the curtain on this amazing trick.
Let's start with an experience we've all had probably 100 times. That moment you open a map and your location just appears.
You don't type anything in, you don't give it any hints, that little blue dot just shows up right where you're standing. To understand how that happens, we need to zoom out. I mean, way, way out.
The answer isn't in a cell tower down the street, and it's not in your Wi-Fi router. The secret is orbiting high, high above our heads. We're talking about the Global Positioning System, or GPS.
Get this. About 20,000 kilometers up, there's a whole constellation of satellites zipping around the Earth. We're talking more than 24 of them, flying in these super precise orbits, all arranged so that no matter where you are on the planet, your phone can always see at least 4 of them at any given time.
Now think of each of these satellites as a kind of lighthouse in space. It's not looking for anything, it's just constantly broadcasting a really simple radio message out into the void. It's basically shouting over and over, "Hey, I'm satellite number 27. I'm at this exact spot in the sky, and right now, the super-duper precise time is..."
So you have a time signal sent from a satellite, and your phone, down on Earth, receives it. Okay, but how in the world does a simple timestamp tell your phone how far away that satellite is?
This is where the true genius of the system kicks in. It all comes down to a tiny, almost impossibly small delay.
So, your phone's little GPS chip does one thing incredibly well. It compares 2 times, the time the satellite sent the message and the time the phone received it. Now, because we know exactly how fast radio waves travel, the speed of light, which is a constant, that tiny little time gap is all your phone needs to calculate its exact distance from that one satellite. It's beautiful, simple physics.
All right, so your phone knows how far it is from one satellite. But that's not super helpful, right? That just means you're somewhere on the surface of a giant, invisible sphere. So how do we go from a huge sphere to your exact spot on the map? Well, let's build this up piece by piece.
The key process here is called trilateration. You might have heard people say triangulation, but that's different. That uses angles. This is all about measuring distances from known points.
So when your phone listens to that first satellite and figures out it's, let's say, 20,000 kilometers away, it knows you are somewhere, anywhere, on the surface of a massive sphere with that satellite at the very center. It's a huge area, but hey, it's a start.
Then your phone gets a signal from a second satellite. Now we have 2 of these giant spheres. And just think, where can 2 spheres possibly intersect? It creates a perfect circle. So just like that, we've narrowed down your possible location from an entire sphere to just a single circle. Getting warmer.
And here comes the magic moment. Your phone picks up a 3rd satellite, which creates a 3rd sphere. So where can all 3 of these spheres possibly intersect at the same time? The answer? In just 2 specific points. We are incredibly close now.
At this point, it's basically a no-brainer for your phone's software. One of those 2 points is almost always some ridiculous, impossible location, like deep inside the Earth or flying through space at 10,000 miles an hour. The phone instantly discards that one. And what's left? The other point. And that is you. So if 3 satellites are enough to pinpoint your location, why does everybody always say GPS needs 4? Well, because there's one sneaky little problem that we haven't dealt with yet, and it all comes down to time. Remember how those satellites have those insanely accurate multi-million-dollar atomic clocks? Well, your phone has a cheap little quartz clock. It's fine for telling you the time, but for this kind of math, it's not nearly precise enough. When you're calculating distances based on the speed of light, being off by even a few billionths of a second can throw your location off by kilometers. This is where that 4th satellite becomes the hero of the story. Your phone is essentially doing a big algebra problem. It has 4 unknowns, your 3-dimensional position, x, y, and z, and the 4th unknown is the error in its own clock.
The signal from that fourth satellite provides the last piece of the puzzle, allowing the phone to solve for all 4 variables at once. It literally corrects its own clock on the fly, which makes the location calculation incredibly accurate.
Okay, so let's clear up one last thing that confuses a lot of people. If GPS works without the internet, why does my map app stop working when I lose my cell signal?
This really breaks it down perfectly. Think of it this way. The GPS signal from space gives you one thing, and one thing only, your raw coordinates. It gives you the blue dot. That's it. It's the internet connection that adds all the useful stuff on top. The internet downloads the actual map images, it pulls in live traffic, it lets you search for a restaurant. They're a team.
And of course, what happens when you go into a tunnel or a deep basement where those satellite signals just can't reach? Well, your phone is smart. It instantly switches tactics, and it starts using the known locations of nearby Wi-Fi networks and cell towers to give you a pretty good guess of where you are until it can see the sky again.
So, the next time you see that little blue dot instantly pop up on your screen, just take a second to appreciate the incredible journey that just happened. You have dozens of satellites, thousands of kilometers away, silently broadcasting the exact time from their atomic clocks.
And your phone is catching those faint whispers, measuring time delays down to the nanosecond, solving a complex 4-dimensional puzzle in an instant, and turning all of that mind-boggling science into the simplest but most powerful statement technology can make. You are here.